What's going on? I'm sure a lot of you are really disappointed that there's no dumpster fire today. So that's probably why we had AV. There was no sacrifice to the demo gods. So here we go. You know, it's a little throwback to the 90s. Let's talk about WAF Baby. So anyway, basically this is still my dream. Really, I want more security researchers, you know, starting to look at HTTP2 instead of just one. We're getting more people out there that are looking at it and attempting to work with it a little bit more, but it's still kind of few and far between. So disclaimer, basically everything stated in this talk is to be considered my opinion and not that of my official representation of my employer. Some assembly required, each sold separately, batteries not included, keep out of reach of small children. And just always the reminder, don't test sites that you do not have prior permission to test because that would be bad. So about me, I'm Brett, securitypanda on the Twitters. That's my email, just in case you have to send me hate mail, corrections, praises, maybe some beer, you know, something like that. I am an application security enthusiast. I test pens, I break web apps, I make tasty food, and even though it's slightly less majestic, it's still a pretty majestic beard. So kind of why am I doing this? Again, just to constantly raise awareness of technologies that are out there that people may not be aware of. Obviously looking for WAF bypass techniques, old, maybe some new vulns. You know, we all like to make a little money on the side. I'm not gonna lie, I like money. Pain and suffering, and basically always the throwback to just stop putting shit on the internet. So anyway, let's talk about the protocol itself. So today, it was first published in May of 2015. It was an update to HTTP 1.1. By the end of the year, all the major browsers supported it. And again, it's being utilized all across the internet, Google, Twitter, Facebook, and yes, perhaps your company website. So basically, it's a binary protocol versus HTTP 1.1 being ASCII. It makes the framing much easier and faster. And the fact that it features compression and it'll run over TLS also diminishes the value of sending things via text anyway. It's multiple streams, or multiplex streams, sorry. A stream is an independent bidirectional sequence of frames exchanged between the client and server within a connection. So basically, you get one connection, because remember it's binary, so you get one connection from the client to the server. And basically what it's doing is multi-streaming within that single connection, all the data. It also has HTTPS header compression, but it was found to be vulnerable to breach and crime attacks. And also now, because of that, they've moved over to HPAC, which is header compression. And the other thing that's pretty unique for it is it has like a server push. So basically, when you're requesting, you know, site X or resource X, it preemptively decides that maybe you're going to have some extra pages or resources or whatnot, and it'll actually load those in the background to make everything load a little bit faster. The server push is something a client has to actually be configured to do. And then, so we will move on to the handshake. So basically there's two types. We have the one version that runs over HTTP, which is the unsecured version. It's also considered H2C. And so with the handshake, it's kind of like a traditional GET request that you would see just with pages right now. It issues a GET command, and then if you notice, so the client will actually add the upgrade to H2C in the header. That lets the server know that it is. It actually doesn't support that protocol. And then basically there's two things that'll happen. So the first one is if the server decides not to or does not support H2C, you'll see something like in the first one where it just kind of gives you a 200 OK, it doesn't do anything. If it does support HTTP2, it'll accept the upgrade and reply with the 101 status code, which is switching protocols, kind of like you'd see there. Fun fact, you don't actually see this in Burp, so it's kind of interesting, right? Second one is over secure. The client basically makes the request using a TLS, it's called the Application Layer Protocol Negotiation Extension, or TLS ALPN. So how does that work? So the application layer protocol negotiation, it's a TLS extension that negotiates the exchange of a hello message between the client and the server. And it's basically doing it over a secure connection. It's a lot more efficient than regular HTTP1 because it avoids additional round trips. So basically, the handshake is the client reaching out, saying hello. I support ALPN. These are the protocols. These are the ciphers that I am able to support, and then the server will respond back with the selected protocols and that it also does support it. So it's basically just a quick little two-way handshake. So basically the current security landscape. So, you know, maybe you know, I gave a talk about this last year, and still not really seeing a lot of support on the WAF ends. People don't know if they support it, you know, whatnot, or experimental support, or it's on the roadmap. So, and basically security tools. I found now that there's two proxies that record the traffic, Charles proxy and man-in-the-middle proxy. And still there's no dynamic tools that I've found that are, I would say, open source or on the market besides something that somebody wrote in Go. Really no security tools will be able to scan it at this time. So quickly, like how do I even tell, you know, how do I know that the server supports HTTP2 or that it's running? So there's a little tool called ng-HTTP2, which is part of the ng-HTTP. It's a proxy. And basically what ends up happening is you're going to look at this connection, and it's going to go ahead and tell you the negotiated protocol, which you kind of see highlighted as H2. It'll go ahead and walk you through the entire connection process, and it'll actually tell you if the server connects via HTTP2 or not. So a fun little fact is a lot of times we'll run into like CDNs or whatnot. So I mean, some of you that do web pen testing or deal with that kind of know how fun it is to deal with CDNs sometimes. And the thing that I found is Cloudflare really loves to use Nginx. And so they're all running Nginx with H2 on there. And so the fun part with that is it does show that at the CDN level. However, when you actually look at the entire connection, it ends up downgrading it, you know, at the server or load balancer. So that's kind of why I like this tool. It lets you know. Unlike other tools, will tell you, oh, I'm using H2. No, you're not. So basically, let's talk about the bypass. Cool. I love fat Steven Seagal barely making an effort. It's beautiful. So basically, the things that I'm kind of talking about, I'm going to say it's not really a traditional bypass. You know, when you look at like WAF bypass techniques and whatnot, I mean, you see these guys that are, you know, encoding and things like that. And really, we're not really doing that. We're just kind of going, oh, you don't support this protocol. I'm just going to walk right around you. And the fun part about that is if they're not getting you at the WAF level, then basically it's a lot of fun for the IR guys and PCAPs and whatnot, because all you're going to see is this HTTP2 web traffic going back and forth, and it's going to be encrypted because it's SSL. And because of that, like unless you're actually doing like SSL inspection at the firewall level, it just looks like a regular packet. They're not going to see an attack. They're not going to see you exfiltrating data or anything like that. They're just going to see web traffic. Yay. So again, that's kind of why I just say that we're hiding in plain sight. So basically what I'm going to do is I'm going to go ahead and kind of go over some steps. You're not going to be able to take notes on this, trust me. I mean, you will, but there's a lot of kind of stuff, and I'm just going to kind of scroll through it. So basically, one of the things that I found is, as I said, burp does not support HTTP2. So what happens if you have a client or site that you want to test through burp, and you want to trick burp into thinking that it's testing over H1.1, but it's actually sending everything over HTTP2. So first part is you're going to install the ng HTTP2, which also includes the package for that. Of course, I'm a Mac user, so this is how to do it on the Mac. So the first step is creating this browser to burp config file for the first engine, for the first proxy instance. Basically, that'll convert all the H2 requests from the browser to an HTTP 1.1 request that's sent to burp and vice versa. So basically, this is the first part that we'll talk between the browser and burp. So the second step, you're going to create another file for burp to server config for the second instance that will be converted from HTTP 1.1 request from burp back into an H2 request that will be sent to the server and vice versa. The next thing, you're going to create the self-signed key and the cert for the config file. And basically what you're going to do is after that, you're going to run both instances of your proxy. And then so you're going to configure Firefox to proxy the requests to 9080, and then another listener report of 9090. And so basically, on the project options connection tab, you're going to add the new entry to the hostname resolution table and resolve it to 127.0.0.1. And that's a test Akamai site. And basically, you get this. And it will go ahead and do that. So basically, it's tricking burp into thinking that it's using a different protocol. And again, certain WAFs don't even support it. So you can, when you're forcing the traffic through over H2, you're going to see some different stuff. You may see things get dropped. You may see things connect. You may see nothing in front of you. It's kind of fun. And again, it's the fun part about is if it's not going through a WAF, they don't see it. It's web traffic to them. And most of the time, hopefully, they'll just ignore it. Tips for defense. Basically, if you don't need it, turn it off. Make sure your WAF vendor actually supports HTTP2. If they don't, turn it off. And I mean, really, just turn it off. Basically, there's a list of resources that basically people are continually contributing to. So it's always fun. Developers build tools that we can turn around and use for nefarious means instead of testing. And so these ones, the top two are good. There's a list on GitHub of known HTTP2 implementations as far as like what vendors and technologies support it. And the bottom one is the actual RFC with a list of security concerns, which is always kind of fun to go through and read. So I guess I talked really fast. Does anybody have any questions, comments, tomatoes, concerns? Come up and dance with me on stage. I don't know. No? Okay. Okay, sure. Guys? As far as what part? Also, so with the binary, I guess, like, it's a single connection. And that's like just one single pipe, and then you have everything multi-streams in that. So every time the client connects to a different server, it's going to have a different connection. Is that, I don't know, is that what you're looking for? More, less, different? I mean, it's ooh, at the protocol level. I can talk to you about that later. We can talk about it, but that's the other fun part too, I guess, is with setting up burp that way, you can only kind of connect to one site. It kind of gets a little weird if you try to do it, just because it's a single connection, and the proxy settings only work over one connection in, one connection out. So no, okay, thank you. I love you all.